And I somehow messed up the share. Okay. So the 75% comes down, and notice that anytime you're dealing with a percent, it's got to be done as a decimal. All right. 75% is the same thing as 0.75. If you are watching a football game and you've got 3/4 through it, that's 75% of the game. 3/4, believe it or not, 3 divided by 4 is 0.75. So 0.75 is the decimal equivalent of 75%. Notice that the decimal is shifted 2 spots to the left. The decimal on this 75% is technically right there after the 5. But if we go into a decimal to do math, which you need to, you can't skip that process, because percents are one of those things that are kind of peculiar to, I don't know what you would say. They're peculiar for being able to, and they're useful for being able to talk to people about proportions. People, if you talk to people about 75.75, that's not going to mean so much as 75%. So anyway, once we've got those things brought down, it looks like this. X is equal to 0.7 times 5 times 4. So that means 3 is what we're looking for. So 3 is 75% of 4. And you can see that, because if you take 3 and divide it by 4, you get 0.75, which is 75%. All right. So here's the next one. 4 is 10% of what number? So the 4 is pretty obvious. It comes down. The is comes down to equals. And what number comes down to X? And the 10% has to be written as a decimal to do the calculation. You can't throw a 10 in there, because if you do, you're going to be off by a factor of 100, because that's what percent is. It means parts of 100. But mathematically, we can't work with that. If there is, it's some kind of bizarre stuff, nobody ever uses, because basic mathematic rules is you're using decimal values. So we're left with this equation. 4 is equal to 0.10x. Now, usually if I'm kind of doing these, I might write them flip-flop, where the 0.10x is on the left and the 4 is on the right. How do I get on? I turn off that people coming in thing. That's like annoying. Is there a way to turn that off? Every time somebody comes in, I don't want to mute you folks if you need to talk. Oh, no, I don't see how to do it. Okay, so dividing both sides by 0.1. That gives us 4. And oh, this is wrong, by the way. I just noticed this. I'm going to put it over here so I can fix it. All right. So let's look at it here on this thing so I can write on it. All right. So this one, as I said, it's wrong. I just noticed, and this should be 40. All right. And the way we know is because if you take 4 divided by 0.1, you get 40. All right. So that's a misprint on that sheet. All right. And then the third type, 9 is what percent of 60? What's missing now is the percent. All right. So 9 is still works like a regular equation. An x, the of is multiplication times 60. Now, generally speaking, when you write it, the x goes on the right-hand side. It means the same thing because that just means x times 60, which is the same thing as 60 minus x, 60 times x. So that means when we divide both sides by 60, then the 9 divided by 60 gives us the 0.15. Now, it wants percent, so we got to go 2 back the other way, 1, 2, and that's how we get 15%. All right, any questions about it? All right, so let's go down to the second page. And I'll give you each a few minutes to work on these, and then I'll come back and check on you, go through them. This is just like the third example we looked at. It's x times 32. What's an x? All right, but it might look more familiar like this. So what percent are we looking for?
50%.
All right, that sounds good. So you divide both sides by 32. And because you're doing it over there, you have to do it over here, but this side's the important part. X is equal to 16 over 32, which is equal to 0.5. All right. Now, 0.5 or 0.5 is the decimal. So we have to go over 2 hops. So that's where we get the 50% at. So 0.5, well, let's put up here. Because 0.5 is 1/2. So 1/2 percentage wise is 50%. Because what percents is, I don't know much about how we came up to using percents, but percent just means parts of 100. You got 100%, you got all of it. All right, try the second one there.
I got 72.
All right. Let's see. So what is, got to convert it to a decimal. So it's 0.8. You can put 0.80 if you wanted to. It doesn't matter about zeros on either side. It's 0.8 times 90. And I believe this was like the first one that we looked at. And that means 72. It's a one-step thing, no dividing. And you can kind of test it by, if you put 72 and divide it by 90, you get 0.8. All right. Try the next one.
I got 50 for number 3.
All right. Well, let's see. Did anybody else coming up with anything?
Well, I have 50.
I got 50 also.
Me too.
That sounds good. Let's see. You got to do 0.6 x. So if you want to look at it, like I said, like this, that's fine. And just like every other equation we looked at, this is the last step for solving an equation. You divide or multiply by the reciprocal of what's in front of the x. And that turns this into 1. And then what did you see? 30 divided by 0.6, 50. And you can kind of see this. If you take 30 and divide it by 50, you'll get that 0.6 back. Oh, and another way, I was going to put these in just to kind of write it out. So we could go back and say that 16 is 50% of 32. Fifty is 80%. Oh, I'm sorry, it was 72. All right, what about this one? That one's going to be tricky because you got to make sure you convert that decimal right.
I got 36.
All right. Let me know if somebody else gets it.
That's what I got.
All right, first of all, four 0.5%. All right, so we're going to go 1, 2. You got to put a 0 over there. So this is equal to 0.45. All right. So we got X is 0.45. Oops. I left out a 0. See how easy that is to do? It doesn't hurt to have that in front. All right, so 800 times 0.045. So 36. All right, so what does that mean? Let's just kind of write it out. 36 is 4.5% of 800. And just to kind of put that in perspective a little bit better, okay, 4.5% is less than half of 10% because it's not quite 5%. If we were to round it off to a whole number, it would be 5%. So 10% of 800 would be 80. So half that again, so it's got to be 40 or less. All right, and that's what that is. It's 36. So that looks good. Hold on a second. Go ahead and start over.
For 5, I got 28%.
All right, let's see. That's what we got. So what percent? Now this one's backwards, but we can still translate it in order. So X and of means times is 14. It's in a different order, but it's really the same one as like number 1. It's just backwards. So then we can write this as 50x because that's 50 times x. Doesn't matter whether you got the 50 or the x first. It's just that generally we look at it like that. So I'm putting it in a familiar form. So those are gone, and we got x is equal to, and 14 divided by 50 is 0.28. And then see what we do. 1, 2, it's equal to 28%. All right. Keep on going. And like I said, to turn it around, again, that's 45x. That's how you're used to seeing it. Is equal to 15. Now this would make it a little bit of translation. So that means x. And what happens when you do it? Let's look at it. I know that that's 1/3, but they want to know a percent. So how can we handle that? All right, let's look at it here. All right, 0.33333. Now, back before we had CDs, and then of course, even, I know that we still have CDs, but not so much. Usually it's just, MP3s or whatever people download now. But anyway, before CDs, you had these called LPs or albums, and I think they've recently made a comeback because people think that some people think they sound better, and you have to play them on a turntable. And what speed did they run out? Well, this right here simply means that this just keeps repeating. So when we come over the 2, we just write it as 33 1/3. Because this, as a repeating decimal, means 1/3. And the speed of those turntables, like I said, for those long plays is 33 1/3. In other words, if you do it, in 3 minutes, you get 100 rotations exactly in 3 minutes if it's at the right speed. Come back in and write the 1/3 there. All right, questions about that? All right, let's look, go on down. All right, try number 7. There's one more. It's not like that one. It's a little bit different, but I think it's number 8. You just got to watch. Well, you don't really have to watch anything. It's just that when you get it, you're going to wonder what you got, probably. I'm going to do a yell out here, see if any of these people.
27 for 7.
Okay. All right, is Christy in here? I didn't see her. Raven? I don't see her. She's usually got an R up there. And Chelsea? I don't see. Okay, I just want
He
to.
or the other Chelsea? I'm guessing the other one.
Oh, Satcher?
Yeah.
Is there another?
Yeah, I can. Sorry.
What's the other one?
Dufresne.
Oh, Dufresne, yeah.
That would be me.
Yeah. Yeah, I already got that. Okay. So it was the Chelsea Satcher. All right.
I got a 2.7 for number 7.
All right. Yeah, and that sounds about right. Now you got 3% there. So let's write 3% over here. All right. So that's 0.03. All right. So that's 0.03. So its x is 0.03. And this is just a plain old multiplication. And it's not even quite a third of 10%. I mean, if it was 10%, it would be point, you know.
Okay, I put my decimal between the 0 and the 3.
But that's 30%. Okay. So if you got 30%, so you're saying you've got this, right? That's why this is important, is if there's nothing else on the side there and you need to go over that second decimal, you got to add a 0. Think of it like this as well. 3% is, 3 parts of 100. Our money system is actually based on decimals, so there should be some help. So 3% of $1 is 3 cents. And this is how you write 3 cents. If you ever look, on your receipt where you got change, I think it looked like that. I don't have any receipts on me, but I think pretty sure that they still do that. That means 3 cents. 3%. 3 cents is 3 parts of that 100. So our dollar, in a sense, works just like the percents, but it's got to be written in the decimal form. Because if you were to do that times 0.3, there's quite a bit of difference. See, 0.3 times 90, see, it's 27. That's a whole different animal than 2.7. All right, so what is that? I'll just type it out. $2.7 is 3% of 90. All right, what about 8?
Yeah, 150%.
Okay, good. That's what I figured people might get hung up on this one, but looks like you're doing all right. So X is what percent of is times 80. And then, as I said, I'm just going to write it the more familiar way. I can do that. 80x is equal to 120. All right, now divide both sides by 80. You can handle it like that if you want to. You just got to remember that you would still divide both sides by 80. So we can simplify this a little bit at a time. It's 12 over 8, which is actually 3 halves. But we're going to have to put it in a percent. So let's put it in as a mixed number. That's 1.5. This is one time when being able to put things in a mixed number is useful. All right. So 1.5, we still have to go in the other way to the right. 1, 2. So 1.5 is equal to 150%. And that's the challenge of going back and forth between decimals and percents. 1.5 is more than one whole. And it's a half times more than a whole, so it's 150%. All right. So we got a couple more to go, and then it looks like the My Math Lab is working, so I'll take you back over there. All right, so 15%. So it's got to be written as this, or it's not going to be any good. Of, so that's multiplication times x is 9. So we know the percent, we write as a decimal. The what of means multiply. 0.15 times x is equal to 9. I'm going to, I can do it here, I guess. So all of these are really just one-step little problems once you get them set up. So 60. So what does that mean? That means 15%. All right, what about that last one?
I got 16.
All right, let's see.
I'm going to say 0.16%.
All right, so let's look at that last one. What percent? So it's x times 25. Put a little dot in there, we'll change that in a minute, is 4, which is essentially 25 x is equal to 4. Yeah, I think that's what it is. That's 0.16. So 0.16, which is equal to 16%. All right, any questions about those things? Okay, I was going to show you over here in the My Lab thing. So you should be able to check out So just remember, I'll give you a couple of things. Everything from, I'll do it by homework first. All of these here are going to be coming due by the next time I see you. Everything from here down to right here, okay? 2.5. This one is wrong. I need to fix that. But see if I can fix that. That's in the next lesson. We want 228 on that. All right. All right, so everything from here on up, like I said, to be due before we come back on Monday. Now, here's the important things. It's the test, because the homework is a very small portion. All of the homework together is like one test grade. Even if you max that out, you're not going to be able to, and don't do anything else. It's not going to do you much good. You got to perform on these tests. All right. So you have a quiz. I don't know. Does this quiz too? Let me see. Does that belong to us? I think this is for the next section. Let me make sure. Let me make sure about that. I just assumed that was ours, but it doesn't tell us what chapter. Hold on a second. I'll be right with you. Yeah, that's for the next section. Okay, that's why it's got a different date. All right, so the quizzes and the tests are also active now. When I say quizzes, both of these things in yellow are quizzes. One is it's a quiz. It's called a quiz. And then the practice test is also a quiz, coded as a quiz, but it's basically made out just like the actual test you see there. All right, notice that, let's see, when do I have this opening up? I'm going to have this opening up on Sunday. So if you want a weekend day to do it, you can do it on the 7th. The 8th, when we're back in class, it'll still be open. We'll use that as a day of review. And then it'll be due the next day. When the stroke of midnight comes, we're looking forward to the next material, which is in chapter 3, okay? Because 1 week from today, actually, we're starting new chapter, so the test is gone, all right? Any questions? Okay, so the thing about this is, and like I said, I can't show you because I'm not a student, but if you click on here, see, it's not got but a couple questions on it. I had already tried to do it because, like I said, it doesn't treat it the same way for me. But I checked it and the proctor said, but anyway, that's the one you can test it on. Now, if you don't get it on this, I mean, this is going to go away by, the time we come back. But if you don't get your proctor thing running, you don't need it on this test, but we will need it on this test. This will be a trial run for the midterm. All right. So I would recommend getting your ProctorU to work on this before it disappears. All right. So any questions that you can think of? Anybody got any questions before we? All right. There was something I was going to do. Oh, it's probably in the other class. All right. Well, I'll tell you what. Let's just take a little break, and we'll come back in about 5 or 10 minutes. All right. And we'll jump on section 2.5. Okay. This last section that we're going to look at, it's kind of bizarre in a way, but it's the same technique that you've been using when you're solving equations. The only thing that's going to change here is that you may not know what other variables are equal to. Now, the first set of problems you're going to see down here, there'll be a couple where you can do that and solve just like regular equations, and you can fill in the variables. But on these examples that I'm going to go through here, you're going to still contain variables in the solution for a given variable. So and if you don't catch on to everything here, then I would say just make sure you understand and can do example 1. Because example 1 is something that's going to be very useful in, I know we start doing it in chapter 3, but I think we do it towards the end of the class too in an algebraic way, which is why this is very helpful. Because this right here is it's a linear equation. 8x plus 6y is equal to 24. And if we solve, this is what we call standard form. You'll learn about that too. And then if you solve this, I'll go through the process in a minute. You've got y is equal to negative 4/3 x plus 4. Those two are actually the same equation. All right. This is just what we call the slope intercept form. So if you remember anything from recently from algebra, that should be something that might be something you remember, because when you have the slope intercept form, just at a glance, you can tell that the value in front of the x is the slope for a given line. And then the one hanging off there at the end, positive 4, is your starting place. In other words, that's the y-intercept, and that's where this line is going to cross the y-intercept, the one going up and down like that. So you can easily graph using an equation in that form. But we're not going to worry about that now. Now, so how do we solve for the variable y? Well, y is right there next to the 6y. So what we got to do first is we got to eliminate the 8x. We don't want it on the same side. That's all the same things we've been doing to solve for a variable. So we're going to subtract 8x here, and if we do it over there on the left, we got to do it on the right. 24 minus 8x. Now that means 6y is equal to 24 minus 8x. Now we got to divide by 6. And if we divide this by 6 in order to get y, we got to divide these other two things by 6. So 24 divided by 6 is 4. 8, 6 negative just simplifies down to 4/3. We can't bring that down to a whole number, so it stays as negative 4/3. Now, as I had said, this right here, if you read it in that direction, y is equal to mx plus b. This right here is your m, your slope. We'll learn about that later. And this is your y-intercept. But this is by far the most important thing to carry out of this 2.5. These other ones are kind of, I don't know how you would say them, but let's look. All right, for all of these, they want us to solve for y for some reason. I guess that's just a coincidence, but all right. you got m is equal to dx plus cy negative 5. The y is right here, the cy, it's got a c multiplying it. But first, we got to get rid of the dx, positive dx, and the negative 5. So what does that mean? We subtract a dx. We add a 5. And those just collapse and they're gone and we're left with cy. But over here, they stay because there's nothing to connect them to. There are no like terms to collect there. That's what's different about this. You can't put together m minus dx plus 5. So you're just going to leave them like that. Now, to finish solving for the y, you divide by c over here, and that gives you the y. But you also got to do it on the left. Now, since there's no way to simplify in here, in other words, m not divisible by c, dx is not divisible by c, and 5 not divisible by c, we're just going to leave it like that. Y is equal to m minus dx plus 5 all over c. All right, now, this is just a one hot problem. We still want to solve for y. Y has got 2mn next to it. So that means we got to get rid of the 2mn that are multiplying. So we got to do the opposite, which is divide by 2mn. And that gives us just the plain y. And if we do it on that side, we got to do it over here. We got to divide the x by 2mn. Well, that's all there is to it. It's done on that one. They probably should have put this one up there first. I mean, second, at least.
Yeah, that would have been easier to understand.
So try these. These right here are just filling in some variable values, and then you're going to have to solve for something that may not be on the, you're going to have to do a little division or multiplication or something in order to get it. So I'll give you a couple of minutes on those. And then if you get an answer on one of those, let me know. And then when I think that people have gotten a couple of these, I'll
Professor Cruz?
start going over them.
I don't know why you can't hear my mic. Professor Cruz?
Mr. Cruz? I don't think he can hear us.
Yeah, I'm testing my mic just to make sure. Professor Cruz? Yeah. Okay, at least I can hear you. I thought I couldn't be heard on the other end at all. I'm not sure why he can't.
All right, anybody come up with anything on those?
Can you hear us, Professor Cruz? Type it in the chat. He'll probably see that.
Thanks.
All right, so they're telling us that V is 56. We don't know the L, and the L is kind of hard to write. It's a script L, small l. And then the W is 4. And the H is 7. So 56 is equal to 28L. And then if you want to, you can turn it around. Did anybody get anything yet? I do believe this comes out to 2. Yes, it does. So these are kind of
Professor Cruz.
Can y'all not hear me?
No, you can't hear us.
What happened to my sound?
Yeah, Professor Cruz.
Okay,
Can you hear us?
I can hear you now. I don't know what happened.
Can you hear me, Professor Cruz?
Yeah, I can hear you now. I don't know why. Somehow my sound got turned off.
I was trying to call you since the break.
All right. Well, let's stop. And that's what did you have questions about?
No, it's okay. I figured it out, but
Okay. I don't know what happened. All of it, some reason my audio got turned off. I don't remember doing that. I'm glad I finally looked up. Of course, I got one class that's quiet, and they, I could go through the whole lesson and they wouldn't tell me anything. Or somebody would send a text and I would see it at the end. I wish they would put the text out
We've been trying to
front.
write you in the chat the whole time.
Yeah.
exactly.
All right. I don't know what happened. So at 6:42, so somewhere it got turned off. Was it turned off? I wonder if it turned off before the break. I wonder what I did.
I could hear you during the break, but you couldn't hear me.
You can hear us.
Yeah, but I mean, I don't know what happened. All right. Well, I'm glad I got y'all back. All right. So y'all okay on this?
So far.
All right. So this one, it's got the 186. And you just got to watch. They're going to be, there's no L. They don't tell you that. I'm just going to put it as a capital L. And then the W is 3. And we'll come back and handle that. And then this was 2. So right here, because multiplication is commutative, it means you can multiply 4 times 3. And put it in front of the L. And then this is just 30. And then this is just like a regular equation. All right, so these are just kind of warm-ups to let you see. Kind of how multivariable things work. But the problem is going to be down here is you're always going to keep that other variables in the mix. So L ends up being 13 there. All right, so so these are the ones. All right. So give that first one a try and let me know if you're able to come up with something on that one.
For number 3, I got y equals 11 minus x.
All right, let's see here.
I got the same.
All right, so on this one, the only thing that's stopping it being solved from y is that x. So we got to get rid of that. And if we do it over there, we got to do it over here. So y is equal to, and if you got to 11 minus x, I mean, I'd be happy as all everything, okay? But generally speaking, This is the form for, like I said, we'll learn about later. But those two things mean the same thing. It's just that when it's in that order, like I said, it's inside of the y is equal mx plus b format. Okay, so all right, what about on 4? All right, so this one's got a couple of steps on it. All right, so we're solving for y on all of these. So that's what we got to keep. So we got to get rid of so 5y is equal to negative 3 x plus 15. All right. Now, since this one wasn't a plain y like number 3 was, then we've got to divide by 5. And remember, we got to divide every term by 5. I'm going to do them separately. It kind of makes it a little bit easier to understand, I think. Now, there's nothing in 3 that we can divide 5 into, so we're going to leave it like that. So that's 3 fifths
Plus 3.
Yeah, and 15 divided by 5 is 3. Good. All right, try that next one. That one is a little bit different, but same procedure. You got to get rid of the x first and then divide by negative 4.
I don't know if I'm correct, but
Mhm.
I got
Okay.
y equals 3 over 2x minus 13 over
Yeah,
4.
13 over 4,
Yeah.
and it should be negative 13 over 4, right?
Negative 13 over 4? Because I thought it was the
All right, well, let's just see.
with the two negatives.
I'm doing it in my head, but I think that's what we need. Let's look. So first of all, we got to get rid of the negative 6x. All right. Now we got a negative 4 there in front of the y, right? Divide each one of them by negative 4. So this means that we just a y. This is negative over negative. So that's positive what? 3 halves. We just reduce it down. We can't make it a whole number. We don't want to. 1.5 wouldn't help us for the purpose we're going to use this later. All right, now what about this? We got a positive 13 divided by a negative 4. So that's a negative term hanging off the end there. All right.
Just a quick question, like I know when you simplify it, it still breaks down to the negative 13 over 4, but initially shouldn't it be plus negative 13 over 4?
Well, but that's the same thing.
Yeah, that's why I was just wondering, like if we're
The thing is, it's just that when it's in this form, it's generally considered simplified, and that means it's negative 13 over 4.
okay,
But if you'd had,
the plus.
plus negative 13 over 4, that's the same thing.
Okay.
All right. All right. So these next ones are not nearly as important, but let's go through these. Like I said, these are just formulas in general. I'll tell you what, I'll show you one formula that's real famous here. Most everybody's heard of this one. So that is essentially energy is equal to mass times the square root of light. I think that's what C stands for. And it's solved for energy. Now, if we wanted to solve this for M, let's say, well, I'm sorry, yeah, let's solve it for M, then we got to get rid of these C squared things. So we divide both sides by C squared. So that means M is equal to energy over the speed of light squared. Now, I can't really show you how to solve for C yet because technically we haven't learned how to do square roots, but what you'd have to do is take the square root of both sides. And it essentially creates two possible C's, one negative and one positive. All right, so go on to this next one. One thing might help you is to circle what it is you're trying to get at, the T. These are all three different, oops. And that one's the F. Well, I can't really circle it too well, but anyway, let me know when you get these. These should be just one. This one is just a one-step problem. And the rest of these are going to take 2 steps. Actually, you could probably do them in the last one in 1 step if you wanted to, but all right. So on this one, you want to keep the T, so you're going to lose the R and the S. And if you do it on that side, you got to do it over here because this makes them go away. When you divide R by R, you got 1. When you got S by S, that's 1. So you got M okay. So T is equal to M over R S. Okay. This next one, I think that's the formula for simple interest. So you might have to fiddle with that if you were in a finance class or some other business class. That's one you might see. These other two on 6 and 8, I don't recognize those. It might be something that just somebody made up here for this book. All right, so on this one, you got to get rid of that P hanging off first. So the P is being added. So you got to do the opposite, which is subtract. So now that P, subtracting it, only got rid of that one right there. Those are the ones that are going. The PRT is still left over. All right, so now to get to the R, we got to lose the P and the T. Now here, they're multiplied times the R, so we do the opposite, which is divide. Divide both sides by PT. Over here, it's got the, what it does is the one P takes out the other, so we just got one R left, or we just got one left, and the T over T is just one. So what we got left is just R. So, I mean, if we were wanting to, then this is solved for R, which is rate, because this is the amount is equal to the principal plus the principal times the rate times the time. This is back when actually having money in the bank actually accrued some interest. So you could find out if your interest was 3%, you know, how much you would have after a year. So what this would tell you, though, is solve for the rate. So that means that the rate, you could find out what the rate is by taking the difference between the amount and the principal and then dividing by principal times time. Okay. All right, look at that last one. I'll give you a little hint on what you can do. If you multiply both sides by 4, remember 4 and 1/4 are reciprocals of one another. You'll end up with just FK when you do that, but you'll get 4D. All right. So try multiplying by 4 and then dividing by K.
Professor Cruz.
Mm-hmm. What's up?
I got 4D over K equals F,
All right.
or
That might
F
be right. That might be right.
4D over K.
Let's try. Like I said, I'm going to multiply by 4 just to clear that fraction. And remember, when I'm multiplying by 4, I'm multiplying by 4 over 1 times 1/4. And then the F and the K are still there. So see, when you multiply the reciprocals, you got nothing left. You got 4D is equal to F. K. All right. So now we want to solve for F, so we're going to get rid of the K. So it's multiplying F, so we do the opposite, which is divide. And that gives us F. So you had it right, I think. Is that what you had?
Yes.
Okay. Good job, Trinice. Yeah, those are tough. Well,
I was lost
pretty,
at first.
well, like I said, this is tough. This is tough for people to do. I mean, I know that math in general is, but these are the ones that are going to come in later, handy later in the course. So that is why, main reason why this is introduced here, because since you're solving for equations, they throw in solving, for variables when you still got other variables in there.
I think
All
that's
right.
where it loses me at some point. It's
Well,
so many
like I said,
variables.
but the rules are not really changing. We didn't really introduce any different rules here. We're still using those same basic properties of addition property to clear anything that's added or subtracted to what we don't, what we're going to keep. And then the final one is, then that's when you do the division by whatever is multiplying the variable that you want to keep. Now, this one is a kind of an exception because people don't think of multiplication. I'm sorry, they don't think of division as multiplication by the reciprocal. So when you've got a fraction here, then the reciprocal is the same thing as 1/4 divided by 1/4 actually still does equal 1, but it's 1/4 times 4, which also gives you 1.
Well, that's why it became more familiar to me.
Yeah.
I saw that.
So, all right. So, that's all the material. If y'all want, y'all can use the rest of the time to work on to try to catch up with your work if you haven't got it. And you can answer me any questions, and I'll stick around here because I don't really know what else to show you because we pretty much finished everything. So you want to start making sure that Monday, if you still got blanks on things you don't understand, bring those questions back, okay?
Professor Cruz just said a Proctor U. We want to do a test run on that. Do we necessarily have to complete it, or?
Well, it's not much to it. Let me show you again. Okay, the first thing, what in the world's going on here? That happened? I don't know. I might need to reboot my computer. But the reason why you want to do that is because the midterm has to be proctored, all right? It's got to go through that Proctor U. All right, so this is kind of we'll have a test run on test 2. You'll have to take it with the Proctor U. But this little thing in here was in here for the very reason that you want to make, okay, it looks like it's working now. I thought for a minute it wasn't. All right. So under assignments, all right, I'm just going to put it on quizzes so we can see it. So after you finish your homework, you also got these 3 things to do. This one is not really got much anything to do in it. It's just to run a check on that system to make sure you have it. As I said, this is the procedure you got to do. It's also this is all mapped out if you like reading documents. But I was trying to give it to you in just a nutshell.
Mhm.
This one is, they don't do that anymore. Don't let us do that. So you can't see it anyway, but what you got to do is you got to go to ProctorU. You sign up. In other words, you got to create an account,
Mhm.
and I can't, and you're doing it as a test taker. All right. And you can put in there the institution, or you may have to add it. I don't know why there's nothing there, but anyway, you got to fill out. Well, there it comes.
Okay.
So then you fill in all this, and then once you do it, and you may have to, you know, you got to check all these things and fill it in. You got to tell them you're not a robot. And then when you do create account, I think that's enough. But then you got to have your information when you go back, because you're not going to do anything ever here again once you created an account.
Okay.
I had somebody the first time, they were trying to find the test on there. The test is not on there. The test is,
In our
oh,
site.
this would be the one that you would use. And when you run it the first time, and maybe when you hit start, like I said, mine's not a student account, and mine's still saying finish. I'm not sure why.
Maybe because you went in the first time.
Yeah. Oh, I got to hit submit. It's got multiple attempts. Now it's on me. I haven't finished it, but anyway. But see, this is what you can do if you take like the practice test. There's the review option. So that's where you go back and you find out what you did wrong. They even let you have helps to figure out for the ones you got wrong. They don't give you the helps during the test, of course, but anyway, once you do that, it's going to prompt you to download some kind of an app. Let's see if I can find what it's called. So I mean, it's in here, but I think it should prompt it for it. But you need to have that on here. And anyway, once you do it, it'll ask you to log into the account. You're going to have to log into the account. So you got to remember your information. Log into your account on ProctorU. Then it takes over your camera and your audio, your microphone. So you got to hold up your ID. I think it'll just tell you all that. And then it'll watch you throughout and make sure you're not doing anything fishy. It'll record it. And ProctorU is one that's actually doing it. And Delgado's paying them for it so that I don't have to watch it, because I don't see how, you know, I guess I could have, I don't know how many people we got in here, like 20 people on here testing at the same time. But since Delgado's willing to do this, we're going to let them do it. Somebody's looking at that video and they'll tell me if there's anything fishy about it.
Right.
I can also go back and look at them if I want.
Gotcha.
So, you know, basically, you know, you don't talk during the test. You don't, you know, look at any other sites or anything like that. You know, you're not doing anything on the phone. You got just the calculator. And actually, since my math lab has got a calculator built into it, I would just use that one.
Okay. All right.
You know, for the most part, because that way there's no, you know, there won't be any question.
Right.
Because, you know, some people will be, I've seen people cheating and I know what they do. And one of the things, I mean, I hate to bring it up, but I know that people can use their phone to cheat. So that's why you don't want to use a phone and have it accessible, you know, while you're on the test. But that is not going to be an issue until the midterm, all right?
Okay.
But we are going to have a dry run on this test, which is
The
a
one
little
that's
bit
more of a
later. It's at the
minimum.
end of of the month.
Okay.
Because believe it or not, after next week, we're going to have a whole week off for Mardi Gras.
Mhm.
And then we'll just have 2 more weeks. It might be just 1 week. Yeah, it might just be 1 week afterwards. I got thrown for a loop because February came around so quick.
Yeah.
But I guess I can look at the calendar and see.
Yeah. 'cause
But
then it's
anyway,
Mhm.
yeah, next week.
More weeks.
And then we got Monday and Wednesday, Tuesday and Wednesday off for Mardi Gras, even though I guess there's no Mardi Gras. Yeah, and then there's
Right.
1 week. So
Yeah. Okay.
that's right. So anyway, if you got any questions, let me know. I'm going to stay here. I'm
Thank
not
you.
going anywhere. I just don't know what else to show you right offhand.
I appreciate it. Thank you, Professor Cruz. And you have a
Okay.
good
I'm going to stop the recording and then I'm going to upload it when